Welcome back, guys. Today we'll deal with water cycle, right? Along with this water cycle we have similar kinds of problems also, right? We'll deal with the problems in the next part because water cycle is a little bit a big concept. Okay, let's start. Suppose let's say we have taken water, okay, so and we just put that water inside the fridge for one night, overall night. Now what happens? That water gets converted to ice, right? Now let's say this is the cube of ice. I just had taken this cube of ice inside the beaker and I put that beaker over a flame. Okay, so let's say this is just stand maybe, right? So by using the thermometer, okay, a laboratory thermometer maybe, right? So I simply identified its temperature as minus 5 degrees centigrade. Okay, maybe some thermometers doesn't contain some negative powers also, but okay, no need to worry. Okay, by using the fridge, okay, we could easily say it is at minus 5 degrees centigrade. Okay, now while after I just had heated it, right? What I'm doing now, I'm just heating it. So after I had heated it for some time, I just simply observed something that is nothing but, so the temperature just got raised from minus 5 to, it becomes minus 4, minus 3, minus 2, minus 1 and 0. Exactly at 0 degrees centigrade, there is no rise in temperature, right? At minus 4 it is still in ice. So it is still in the form of ice also, but at 0 degrees also it is still in a state of ice, right? So and at this time, now if you observe, after heating for some time, okay, there is no change in temperature happens now, because at 0 degrees centigrade there is no change in temperature happens, but we keep on heating it, right? Now what happens is the bond between the particles, because the particles just got closer here in the ice cube, right? In the ice cube it is in a solid state, which means the particles were very close to each other. Yes, so there might be bond between the particles. Yes, now after we had heated it for some time, now what happens is the bond, okay, that bond is going to break, right? And to break that bond it requires some heat energy, right? So we are giving that heat energy, right? After heating it for some time, what happens is it comes to water, it becomes water now. Okay, now what happens here is at 0 degrees centigrade water is at two states. One, it is in an ice state, which is means solid, it is in a form of a solid, and on the other hand it is in state of water, which means it is at liquid state. At 0 degrees centigrade water, while might be available in two states, solids and liquids, right? For suppose if you had taken 0 degrees centigrade ice in one hand and 0 degrees centigrade water in other hand, now what happens? It tend to feel little bit colder at 0 degrees centigrade ice cube, because the heat energy that observed is lesser compared to this side, because to break the bond it absorbs some energy, right? Okay, that heat energy is hidden heat energy. What? Hidden heat energy. Okay, that hidden heat energy will call it as latent heat. What do we call that heat? Latent heat. Okay, exactly, the conversion from solid to liquid happens at 0 degrees centigrade, and that thing we'll call it as a fusion. Okay, so exactly what happens here is solid state gets converted to water. Yes, so this hidden heat energy that has acquired by this solid particle that gets converted to liquid particle, it requires some heat energy, right? That hidden heat energy we'll call it as a latent heat of fusion, right? What? Latent heat of fusion. For this case, it absorbs 80 calories of heat energy per 1 gram. Okay, how much heat energy it is going to take? 80 calories of heat energy it is going to take for 1 gram, right? So here in this case, while at 0 to 0 degrees centigrade, okay, minus 5 to 0 degrees centigrade now, okay, we are going to use the formula Q is equal to ms delta T, right? So here Q represents heat energy, M represents mass of water, S represents it is still in a state of a solid, right? So S represents specific heat of ice. You need to use here specific heat of ice value, and delta T represents higher value minus lower value. 0 minus 5, it is minus of minus 5, it becomes plus 5, right? So this is the value we are going to use in problems. Okay, we will use it later. Now if you exactly look into this case, what happens is exactly at 0 degrees centigrade, the water is at solid state in the beginning, and after it gets absorbed some heat energy, it becomes a liquid state. Wonderful. Now after if we goes on heated, now what happens? There is a rise in temperature happens. Okay, wonderful. But if you consider here up to 0 to 4, okay, so the heat energy, it is going to absorb more heat energy, but it doesn't going to raise because there is a behavior, and that behavior we'll going to call anomalous behavior. Okay, anomalous behavior of water. Okay, so at 0 to 4, okay, there is no rise in temperature happens. Okay, there is no gradual rise in temperature. Okay, so that behavior we will call it as anomalous behavior. So after 4, what happens is it comes to 100 10 fraction of seconds. Okay, so it comes to 100, and that overall temperature it gets raised to 100. At 100, the water is in a state of a liquid. Wonderful, right? So now we are still heating it. Yes, we are heating. After heating it, now what happens is there is no rise in temperature happens again. Oh, wonderful. There is no rise in temperature happens. Same scenario here. But here we have a two states, that is solid to liquid. But here what happens is this liquid water gets converted to gas. What? It becomes a gas, which is nothing but a water vapor. It becomes water vapor, right? Now in this case, what happens here is, in this case also there is a hidden heat energy happens, right? So in this case, that hidden heat energy, we'll call it as again latent heat of vaporization. What do we call it? Vaporization. Why? Because that water gets converted to water vapor. Right? That is the reason we'll call it as a latent heat of vaporization. But coming to the its capacity, it is going to absorb 540 calories per 1 gram. Here you could easily see a drastic change here. In the beginning, it absorbed 80 calories per gram, but coming here, it absorbed 540 calories per gram. Wonderful. Now, if you look into the process, now what happens here? When there is a liquid converted to, solid converted to liquid at a constant temperature, that is nothing but 0 to 0, we'll call that as melting. What do we call it? Melting. Wonderful. Now, if you observe, there is a reverse process also there, right? Yes. The reverse process, liquid just get converted to solid, and that process we'll call it as freezing. You need to remember these two. What? Solid converted to liquid, we'll call it as melting, and liquid converted to solid, we'll call it as freezing. Wonderful. Now coming here, what is this? Liquid gets converted to water vapor. What do we call it? Is it evaporation? Is it evaporation? Someone says evaporation, but it's not true. Okay, it's really boiling. What you need to remember? You need to know the difference between these two. One is, what is the difference between boiling and evaporation? Boiling is different and evaporation is different. So no, if you consider carefully, so boiling happens at a particular temperature, that is nothing but 100 degrees centigrade. Okay, so boiling of water takes place at 100 degrees centigrade, but evaporation of water takes place at any temperature. You need to remember this thing, at any temperature. Suppose that there be a stove here, right, and your mother forgot to switch off the stove, and it gets converted to, if the temperature gets come to 100 degrees, what happens? That overall thing gets converted to water vapor, right? So this thing exactly at 100 degrees centigrade, if water gets converted to water vapor, that thing we'll call it as a boiling, right? But same thing happens. Suppose in this case, we are sitting inside the room, and your mother just cleaned the floor right now, and she just switched on the fan. Right now, after it gets rotated for some time, now what happens? It gets rotated, and now what happens is the water on the floor gets vanished. Yes. So in this case, what happens is you hadn't given 100 degrees centigrade here, right? You hadn't given 100 degrees centigrade, but the temperature might be at 36 degrees centigrade. Maybe I'm just taking a room temperature. Okay, general room temperature. Now in this case, what happens here is the water gets converted to water vapor, but that to at 36 degrees centigrade. It is not happened at 100 degrees centigrade, right? So at any temperature, if water gets converted to water vapor, we'll call it as evaporation. Is that true? Yes, right. Now coming to these two, if you look here, boiling and evaporation, right. So the drastic difference is simple. At 100 degrees centigrade, if water gets water vapor, it becomes boiling. If evaporation, what happens is water gets converted to water vapor at any temperature. We'll call it as a evaporation, right? So simply one more example, if you take, suppose if your mother just hanging the clothes, dried clothes on the top of your floor, right? Now what happens? It gets easily, the water gets easily evaporated. So no, right? Did you made a fire here? Right? No, right? We hadn't made any fire here to get that clothes to become 100 degrees centigrade and the water to get evaporated. It is not true, right? We hadn't did anything, but we simply left the clothes there, right? Now what happens is the air that comes and hits it, and there might be molecular reaction happens, and the particles comes down and moves up, and a little bit reactions happens, and now what happens is simply evaporation happens here, right? If water gets converted to water vapor, we'll call it as at any temperature evaporation, okay? But here what happens is exactly at 100 degrees centigrade, water gets converted to water vapor, and that thing we'll call it as boiling, right? So we'll deal with boiling and evaporation much later, okay? We'll deal with the water cycle first, and then we'll deal with it later, right? Now if you look at carefully, liquid gets converted to water. It is also a reverse phenomena of evaporation and boiling also, and that phenomena we'll call it as a condensation. Yes, wonderful. And I think some of the substances, here, while they are at gaseous state, that gets converted to solid state, okay, when they are at gaseous state, but they just converted to solid state, we'll call that process deposition. What do we call it? Deposition. But on the other hand, sometimes what solid state directly converted to gaseous state without touching the liquid state, and that thing we'll call it as a sublimation. What do we call it? Sublimation, right? So from this we could easily learn some of the important concepts. Concept number 1, at 0 to 0, what happens? There is a latent heat of fusion happens, and that thing we'll call it as latent heat of fusion. So that is going to take 80 calories per gram, right? At 0 to 0, we are going to use Q is equal to mLF. F represents latent heat of fusion. Okay, you need to use that formula. At 100 to 100, the process that we call it as the latent heat of vaporization. Okay, simply it absorbs 540 calories per gram. Wonderful. And that in that case also we are going to use Q is equal to mLV here. V represents latent heat of vaporization. Yeah. So for this, okay, wonderful. What about the remaining? There is a minus 5 degrees centigrade to 0 is one stage there, and here in between 100 to 0 we have 0 to 100 is the next stage. In these two stages we are going to use Q is equal to ms delta T, right? So while calculating the problems, I'll just simply explain them. Is that clear? So today we just learned a little bit about a water cycle. Is that okay? So in next class, we are going to complete overall evaporation, boiling, and little bit overall all the topics, and then we'll deal with the problem session. Okay, thank you.